Welcome to the North Plains Groundwater Conservation District web map. Before diving into the Well Buffers tool and the Adjacent Wells tool, I'd like to first demonstrate a very quick version of the Adjacent Wells tool. It's under the Power Tools menu. And if you click to the Adjacent Wells page, you'll find a very simple form where you can enter a latitude, a longitude, and a distance in yards, and you'll get back a list of wells within that distance. And I'll type in 8,800 yards, which happens to be 5 miles, and click Submit. This will include all wells regardless of their status, so capped, plugged, canceled, as well as registered wells, all types, and you can scroll to the right to see additional attributes, including attached documents. Now, before demonstrating the well buffering tool and the adjacent wells tool, I'm going to turn on some additional layers. These layers include the groundwater production units, the groundwater production unit labels, which will show up when you zoom further in, and the groundwater production unit inner buffers. The inner buffer for the GPUs is a strip of land 300 feet or 100 yards inside the GPU, which represents the distance any new well must be from that GPU boundary. We'll also turn on the well class buffers layer. This layer draws a circle around each existing well, representing the area within which a new well cannot be drilled. Finally, I'm going to zoom into Groundwater Production Unit 9551, just because this GPU happens to have some of the characteristics that will help this demonstration. So let's expand the section called Well Buffers tool. This tool has a small form where you can set a class, which determines a radius in yards, and you can also enter a latitude and longitude. These will be the characteristics of a hypothetical new well. Click around on the map and notice that the latitude and longitude changes. If I do have a latitude and longitude already, type that latitude and longitude straight into the form, and then I'll set the class of the hypothetical new well. In this case, I'm selecting Class D. I'm going to place this hypothetical new well just outside this well buffer down here, which happens to be for a Class C well. Note what happens when I do this. I'm going to click Draw because I've got the latitude and longitude set exactly where I want it. Now I've got a circle drawn around the point that I have selected for my hypothetical new well. Note that this buffer around my hypothetical new well intersects an existing well. So this isn't going to work. But I can click a slightly different location and try drawing again, and I'll get a new circle showing me how that one plays out. I can draw as many of these as I wish, and when you find the location that you like the best, click Clear and then click Draw again, and your most recently placed circle will reappear. Print this map to a PDF and save this information, as well as the latitude and longitude of the final placed well. The Adjacent Wells tool is a similar looking form, but this form behaves differently. Instead of drawing a circle on the map, this tool will open a report in a new window showing you the list of wells inside the circle that you've specified. I can choose a distance, and in this case I can use different units and type any lat long into the box or select it on the map. All the well attributes are displayed in the table, including links to attached documents. Note that these tables have a download feature. You can download to a CSV, which opens in Excel. You can also remove certain columns before you download it. And you can use this button to copy the data. It's now on my clipboard, and I could go to another application, like a spreadsheet, for instance, and click Paste, and I would have the data there. For further assistance, please use the NPGCD website button at the top of the map, which will take you to the North Plains Groundwater Conservation District website.